So good evening, everybody. Thank you for joining ACAN tonight for the first of this year's Existing Building Groups case study webinars. For those unfamiliar with ACAN, I'm going to start with a short introduction to the organisation before we continue with the presentations from tonight's speakers. If everyone would mind muting as well, that would be great. So ACAN's mission is to address the way the built environment is made, operated and renewed in response to the climate emergency. As a network of individuals, we channel personal energy, expertise and action towards a common goal, the systemic change of our profession and construction industry as a whole, which we see as a matter of urgency. Our mission is to mobilise a new movement of professional activists towards this goal by building an open, supportive and inclusive organisation. ACAN empowers individuals to proactively seek change and facilitate collective effort through a shared platform built on collaboration. So ACAN has three overarching aims, and the first is to seek radically transform the regulatory, economic and cultural landscapes in which our built environment is made, operated and renewed in order to facilitate rapid decarbonisation of the built environment. We advocate the immediate adoption of regenerative and ecological principles in order to green the built environment, prioritise communities and ecosystems at threat and promote the recovery and restoration of natural environments. We call for a complete remodelling of our professional culture and seek to create an open network to share resources and knowledge to aid this transition. We must challenge and redefine the value systems at the heart of our industry and education system. ACAN is an organisation powered by volunteers and operates without commercial affiliation. As we have grown, we've begun to incur some administrative costs, and we'd like to make sure tickets for these kind of events are free. However, if you are able to make a small donation to keep us going, we won't be able to thank you enough. All donations will go towards future campaigns, events or monthly overheads. And if you'd like to donate, we'll drop a link into the chat to our website where you can find out more information. So tonight we're going to be joined by part of the Entopia project team. So we have Wendy Bishop, an associate at Architype, Lucy Townsend, the head of sustainability at BDP, Peter Kelly, the director of sustainable operations at ISG, and Patrick Watson, partner of 3PM. If anyone has any questions throughout the presentations, do drop them in the chat, as we'll be finishing the event with a panel discussion where we hope the team will be able to answer anything you may ask. So tonight we're going to be learning about the deep retrofit of a former telephone exchange to house the Cambridge Institute for Sustainable Leadership, also known as the Entopia building. Perhaps like others here tonight, I first came across the Entopia project in the RIBA journal. They'd been documenting its progress through each stage of the RIBA plan of work, and to me, their series presented a building that encompasses everything a sustainable retrofit project needs to be. The adaptation of existing heritage asset, the incorporation of biomaterials, using circular economy principles, the upskilling of local trades, and much more. Exceptional retrofit, renovations and heritage projects like this are now not only about the additions of the new or repairs of the old, but need to address wider issues of sustainability in light of the global climate crisis. I'm going to end with a quote from the site Hoardings, which formally read, "This is not an ordinary project, but it needs to be." So if our tech team could please spotlight Wendy Bishop from Architype, and we'll begin the presentations. Thank you.
Thanks very much, George. Just sharing my screen now. Hopefully you can see the screen and hear me. Is that all okay?
Yep, all good, thank you.
Fantastic. Yeah, thank you very much for inviting the team along today to talk about this project. It's been a really fascinating, challenging project at many stages, but one that I think we're all really proud of and kind of really excited to share with you. So I'm going to be talking a bit about some of the initial design stages. Lucy will be focusing more on some of the BREEAM sustainability issues, and Peter will be talking about some of how the contractor was able to deliver the project. If I start first, though, with a kind of a summary of the overall project team, because there was obviously a much wider team involved in this project, and I think it's really important to acknowledge everyone. So our client was the University of Cambridge. Obviously, within the organisation, we had CISL as our end user client, so heavily involved in the briefing for the project. And then appointed a design team back at stage one to do the initial designs up to a planning application. And that initial design team consisted of 3PM as project managers, and Patrick is joining us for the panel after the presentation. Gardner and Theobald as quantity surveyors, Architype, and we were there as architects as well as Passivhaus designers for these first three stages. And BDP as MEP and structural engineers, acoustic consultants, and BREEAM and well assessors, which was a role that they continued throughout the project. And then at the end of stage 3, the project was tendered to a contractor plus design team. And ISG was successful in that, and they brought on board their own design team consisting of Fielden Mawson architects, Max Fordham as MEP acoustic consultant and Passivhaus designer for the latter stages of the project, and Carr structural engineers. And the initial design team of us plus others were retained client side throughout the project to help oversee quality issues throughout. And then finally, right at the bottom there was a separate contract for the interior design of the scheme, and that was E. Waldron Design, who was appointed directly by CISL to carry that out. Just to locate us, for those not familiar with Cambridge, the site is within the Central Conservation Area on 1 Regent Street. It's right next to the University Arms Hotel and Parker's Piece, and that conservation area was really key to this scheme. It's not a listed building, but it does have some heritage sensitivities. It was originally built back in the 1930s as a telephone exchange, and its most recent life before being Entopia was as an office for Cambridge Assessment. And there was a refurbishment done in the late 90s where they added a small extension, which is shown in green in the top right there, and the entrance porch and possibly the escape stairs at the back. We're not entirely sure exactly what happened. And they occupied the building for about 20 years until they moved out in 2018 to their new offices. It's a mostly solid brick walls, although there were some real surprises on site with single glazed sash windows with secondary glazing. And just an image of the building prior to any refurbishment going on. I think one of the key things to note was the original, or actually there weren't original sash windows from the original 1939 build. They were rather clunky replacements from somewhere in between. With the secondary glazing and the dropped ceilings internally, it made the internal environment really quite gloomy. It was the kind of overarching impression of walking around was that it really wasn't benefiting from daylight in most of the spaces. So our brief from CISL, I mean, it was kind of a dream brief in many ways. We didn't have to convince anyone to upgrade it in any way. CISL were really clear they wanted a low carbon retrofit. It needs to be a case study for the circular economy. It should be done to Passivhaus standard, which in the case of refurbishment is obviously EnerPHit. They wanted it to be BREEAM outstanding, have low embodied carbon, showcase lots of innovations, include maximum bio-based materials, and also, and probably most importantly, to show that it could be done on a standard retrofit budget and kind of offer value for money, because it was overall we wanted to show that this could be replicable in many locations. And I'm just showing this graph just to show the kind of scale of the issue with the building. We did this within the first few weeks of the project. We had the meter readings for the last 12 months of Cambridge Assessment's occupation of the building. So the left-hand column divided between gas and electricity. And we wanted to show the scale of change to bring it down to EnerPHit. And there's actually 3 levels of EnerPHit, EnerPHit Classic, and then another couple of levels with additional renewables added in. So there's a slight conversion factor there, the PER factor. So we've scaled up the current or the pre-existing gas and electricity usage. But you can really see it's an absolutely massive reduction in energy use if we're going to go to even EnerPHit Classic, and anything beyond that is a bonus. So how do we start the project? This is one of our initial strategy drawings to kind of when we were thinking about how we're going to tackle this. I've mentioned the conservation area, and obviously, although external wall insulation to the building to upgrade its thermal performance would have been technically easier, we recognised right from the outset that it would have been a bit of a no-go in this context. So we were looking at internally insulating, and that's what that red line all the way around the perimeter of the building represents. What that presents is some real challenges, actually, because with an existing building, you don't have the opportunity to construct details like structural walls coming down and meeting the lowest ground floor in a thermally efficient way. So we always knew we were going to have to tackle quite a number of thermal bridges, both where walls met the lowest floor, also where every intermediate floor met the external walls, and also a lot of challenges around the very complicated roof line. So we were also looking at trying to simplify that roof line as much as possible in what we did. And then another couple of sketches from that early stage, just kind of elaborating on those principles. So the existing situation is illustrated in that top section, a kind of typical floor plate with those lowered ceilings that I flagged up in the photo, which concealed a number of air conditioning units. We had a raised access floor that we would obviously go on to retain. But looking at that proposed section at the bottom of the sheet, this shows that kind of strategy of the internal wall insulation, and where we were going to be meeting intermediate floors, we knew we were going to need to wrap things around both above and below that to minimise the thermal bridge. And then when we came to the windows, we knew we need to upgrade those probably to a triple glazed window to meet the thermal comfort requirements of EnerPHit. But in doing so, as well as changing the windows, we knew we would want to move them back in the facade so that they were ideally in line with that internal wall insulation. So we had as simple a detail as possible and continuity around the building. If we were to kind of keep them out in their original position, we'd have had a very complicated detail at every single window to push the insulation and airtightness line out and then come back in again. So that was really a kind of key change as well. And we had an initial meeting with the planners at quite an early stage to talk about the proposals for the building. And obviously, with the internal wall insulation, there was relatively little change externally. The big thing was to the windows, where we were proposing removing the sash windows and replacing them with windows without any subdivisions, mullions, transoms. So something like on the right-hand side, and planners were kind of flagged their concern at that stage that that was going to be a potentially contentious issue in this context because of the conservation area. So we spent a lot of time looking at this in detail through the early design stages. We looked at lots of different options, this illustrating a kind of range of options that we looked at. And we tested those in different ways. So apologies for the slight graininess of that slide. In terms of the heating demand, obviously, as we moved from, I think it was a double glazed option for option one, all the rest are triple glazed. But the thermal performance of glass is far better than the thermal performance of even a thermally broken window frame. So the less frame, the better the thermal performance. But several of those options could have met the EnerPHit criteria. But what really shocked us in a way was the impact on the daylight factor of removing all the sash bars and just maximising the amount of glass, and that massively increased the daylight getting into the building. Despite that, I mean, and this was modelling that BDP did of the building with the different window options, even with the kind of the best possible windows with recess frames and maximum glass, we still wouldn't have been able to achieve any BREEAM credits for daylighting because the daylighting factor was still relatively poor. And I think it's probably an indication that because the building was built as a telephone exchange, daylight was never kind of high on anyone's priority at that point in time. And so if we were going to radically change it, we would have had to start knocking new windows in the facade, which again wasn't really an option in this context. So we put all these arguments to the planners, and unfortunately they accepted it on grounds of sustainability. So although it was seen as being detrimental to the conservation area, the positive benefits to sustainability of making this change were felt to kind of win out. Just some examples of the drawings that we did as part of that planning application to show that change. And here they are, the before photo, the top left-hand corner, the render that we did as part of the planning application, the top right, and a photo just when the scaffold originally came down at the bottom there to show how it looked. Windows were obviously only a small part of the overall strategy. This is a perspective section to kind of illustrate all the different points. So we've talked about the internal wall insulation. The air tightness was also going to be part of the works that we're doing on the inside of the wall to make the building more airtight. And then various things, including obviously MVHR, which is kind of key to achieving Passivhaus or EnerPHit, having heat recovery as part of the ventilation systems. And that's providing a constant fresh air flow throughout the building. Obviously, we can still open windows, particularly in kind of mid-season conditions, but there'll be times in the winter as well as in the height of summer where we'll probably want to keep those windows closed to maintain comfort levels internally. Obviously, we had removed all the false ceilings from the building to maximise ceiling height and maximise daylight. And we were looking to cover those with an absorbent finish so that we were dealing some of those acoustics within more open plan spaces. And another kind of key issue, which I think I've got a couple more slides on, is the floor finishes. So I talked about the raised access floor. Obviously, we kept that in the building. It was very useful to distribute power and data below the floor, but it was also became a kind of question about what should we finish the floor with. Actually, I'll come back to that in a second. Just a quick one about this diagram around the circular economy, just to kind of try and summarize the thinking around the building, because we'd seen lots of diagrams showing the kind of completed circle around the circular economy, thinking about it from a kind of a material perspective. But this was trying to think about it as a building perspective or a project perspective. We have the existing building, of which we're retaining quite a significant chunk, obviously all the existing structure, and repurposing that where possible. So kind of maximising that retained amount was really key. Obviously, there were certain things we did need to remove from the building, like windows, partitions, and some of the floor finishes. And it was about trying to remove those as circularly as possible. So ideally, sending them off to be reused. I'm sure Peter will touch on that in a minute, as we're all recycled if they couldn't be reused, and absolutely minimal materials being landfilled. And any new materials that we needed to bring in, obviously there were quite a few of those, again, prioritising reuse, or if that wasn't available, recycled materials over any virgin materials as much as possible. And just returning to the floor finishes, there's lots of fairly dodgy carpet tiles around the building. When we looked at it back at stage 2, we looked at all these new finishes and new materials that we're bringing into the building. We looked at what all the kind of possible options that they could be to try and get a kind of sense of the range of impacts from a carbon perspective. And that graph on the left-hand side, obviously, ranging from carpet tiles right at a kind of high carbon impact all the way down to things like lino, cork, down at the bottom. And what we realised, and then the second graph there, just to explain that one, this is kind of for the quantities that we have in this building, what is the impact of this? And we could see that although there was a wide range of materials for each of these different things like ceiling finishes, wall finishes, it was the floor finishes was actually making the most impact. And if we went with the wrong floor finish, just that material in itself could blow our embodied carbon budget for the entire project, which was quite sobering. And so we had to make very careful decisions around the floor finishes. And we realised that actually we had a raised access floor that we were retaining. Could we expose that as a finish? The client were initially slightly reluctant to do that. They were worried about acoustics, slip resistance. But we were able to go and visit a couple of projects which had either new raised access floor exposed or existing or reclaimed exposed, and get some comfort about how that would actually perform in practice. And so for a large proportion of the building, we've managed, it's just the raised access floor that's exposed as the finished. Obviously within areas like toilets and kitchens, we have a different finish that's a bit more functional for those areas. But in some ways, kind of doing the best thing here was actually to do nothing and try and just use what we had. Some photos of the completed building, very similar to the one you showed at the beginning there. The new windows, worked really hard with the detailing of those to make them as slick as possible. And there's some really lovely spaces in the building now. And with the work that Eve has done around sourcing secondhand furniture and furniture showcasing lots of different bio-based materials, it really comes together and feels like a lovely space to work. And then just to sum up, with some of the kind of stats for the building, the embodied carbon assessment that we did at the end of the project to kind of summarize what the building actually does. This is slightly different to others because we've assessed over 100-year design life rather than a 60-year design life. So the in-use carbon is possibly slightly high. But we're coming out with, you know, obviously it's an existing building, we retain a lot of structure, obviously the upfront carbon is great. Over the whole life, it is higher than our original 300 kilogram CO2e per square metre target, but it was absolutely minimised. This diagram that we did using those figures just try and illustrate the difference between if we had demolished this building and built something new, even to the kind of the stretch targets given by Letty, it would have been much more impactful overall than what we did, which is the lower diagram there, where we retained the vast majority of the existing concrete, brick, all those really heavy embodied carbon materials, and really minimise the new material being brought into site. We were set a target at the beginning of 70% bio-based materials, and this was really interesting because even when we initially looked at it, we realised it was going to be a very difficult percentage to meet, and it's partly because it is a refurbishment rather than a new build. In a new build, you might have the opportunity to include a lot of structural timber, for example, lots of mass to really increase that percentage, but in a refurb, we're quite limited in terms of the number of types of materials we're bringing in, and things like a window, although we have got aluminium and timber composite window frames, the glass is always going to be non-bio-based. So we ended up with a total of about 35% bio-based by mass. And in terms of the whole life carbon, just going back to that first graph, looking at it compared to a business as usual scenario with just a bog standard retrofit, with no real energy saving measures, we've managed to save, we think, in excess of 80% whole life carbon, primarily through the reduction in operational energy, through achieving EnerPHit Classic, but also kind of minimising the embodied carbon. And that's me. So I'll hand over to Lucy.
Brilliant. Thank you very much, Wendy. Yeah, hand over to Lucy, please. Could our tech team please spotlight Lucy Townsend from BDP? Just a quick reminder to everyone at in the audience, please could you ask questions that we can pose at the end of the presentations? Thanks.
Thanks, Wendy. Okay, if I just share mine. Hopefully everyone can see that.
All good.
Oh, good, excellent. Right, yeah, thanks, Wendy. So I'm just going to talk a bit about kind of more the kind of holistic sustainability approach that we took on the project, as well as the certifications. So as Wendy mentioned, there was a very challenging sustainability brief, and as part of that, we were going for WELL and BREEAM certification, as well as EnerPHit. So I just thought it was worth starting with this kind of project charter that we had for the project. So we know that we had all those kind of brief requirements. This was about then bringing together all of the kind of ambitions and aspirations for the project, and almost saying, okay, what does good look like? So what is the success criteria we're going to be assessing this project on, but also not just about those outcomes, but about the process of how we get there. So right from the start, it was very important as a team, as well as from the client, that everyone worked together and collaboratively on this project. And so part of that, we all signed up to this project charter. So as you can see at the bottom there, that was all the different members of the team that were there from day one, and the leads of those teams all signed up to say, yes, we are all committed as a team, project team and client team, to deliver these ambitions for the project, which was, I think, really good, and just set ourselves in good stead to make sure we delivered on what we were trying to do. And so just touching a bit on the certification. So as I said at the beginning, when we were discussing setting the brief, we talked about, okay, we don't just want to do some kind of, tick box exercises when it comes to these certifications, but we did want a way of being able to measure the performance of this building, and being able to, this, as Wendy said, we wanted this to be replicable, and we wanted this to be a blueprint for other projects. So to do that, we wanted to be able to measure the performance and actually have a badge that said that we had achieved something really good. So we looked at BREEAM because obviously there would be a planning requirement, and it's just something that's well known in the UK as an environmental assessment methodology. WELL was probably still fairly new when we started talking about this 3 or 4 years ago, but it was growing in prominence for especially office developments. So that was all about focusing on, the health and well-being of the occupants within the building, and that actually aligned quite well with EnerPHit, because that's not just about low energy. And that's also about providing, you know, exemplar comfort for the users of that building. We did also talk about SCAR for offices at the beginning, but we felt that that didn't really add much additional value to what we were already trying to do, because a lot of the elements in that were already covered within BREEAM or WELL, or just within some of the other brief requirements that we had. So the brief was then decided that it would be BREEAM and WELL and EnerPHit. And this table here, we just started trying to map of, you know, what are the requirements within each of these that will start to inform some of the design decisions that we needed to make, and also where there was kind of overlaps between those. And that then translated into this Venn diagram that was produced. So this was taking that previous slide around the actual certifications, but expanding it to all of the other brief requirements around sustainability. So talking about, as Wendy mentioned, you know, the use of bio-based materials, looking at how we drive down the embodied carbon, but also about kind of, you know, functional adaptability of spaces. So it was really working with the end users. So throughout the whole process, we had some collaboration workshops, and that was making sure that all of our design decisions, we were feeding those back to CISL and the group that were actually going to be, you know, using that building at the end to almost test those ideas, but also understand what their requirements were from spaces, and how flexible, how adaptable did those spaces need to be for the actual work that would be ongoing within the building. I suppose slightly challenging that we started this project before COVID, and then obviously during COVID and after. So a lot of those, you know, hybrid working was probably not as prominent when we first started this project. So actually being able to build in that flexibility for almost like a post-COVID world was really important. And it was just about, as I said, mapping this so we could start to see where there were overlaps in what we needed to deliver for design strategies. And it was almost seeing the benefits of looking at these different accreditations. So, you know, EnerPHit, BREEAM and WELL, you can see in the middle there, even though they're different standards, they all tend to have, you know, the same goal at the end of the day. They all want to maximize the performance of the building that we are designing and occupying. And it's not just about the performance of that building, it's also about the user experience. So this project was very much about how do we deliver a low carbon building, but one that is comfortable for the people that are in it, and also actually, you know, is a positive benefit to their health and well-being. And then the other part, Wendy touched on this as well, was cost was quite a big factor in this project. So we didn't want this to be, you know, a once-off exemplar sustainability scheme that everyone just assumes then costs more money and therefore cannot be replicable when you're on challenging budgets. And we all know that within the construction industry, you know, material costs, other costs have been increasing. So it was really important that we could demonstrate that this could be delivered within you know, a challenging budget. So all of the decisions that we were making, we looked at it from a cost benefit point of view. So this was just examples from when we were looking at what BREEAM credits to go for. And we were saying, okay, well, where are the, you know, the almost low hanging fruit, the easy wins that we know we can get for a relatively low cost, but also a low design complexity as well. And then as we started getting up to the higher cost and higher design complexity ones, that was then a discussion within the design teams as well with the clients of saying, you know, is this the right strategy? What are the alternatives that we can look at? And some of those things, like Wendy said, you know, things like the floor finishes, that meant that there was an embodied carbon saving. It also means by just emitting materials within the building, there was also a cost saving associated with that. But it was also really keen for this project that it wasn't just focused on capital cost. So what we wanted to do was look at the whole lifespan of this building. So we did a lot of life cycle costing as well as life cycle carbon assessment. So that was looking at, okay, yes, you might have 3 different design options, but just because the lowest capital cost doesn't mean it has the lowest overall life cycle cost. So we worked with the cost consultant to look at, you know, replacement cycles, maintenance costs. That was something that was really key to work with the end users, so to work with CISL and the University of Cambridge, who supporting the maintenance of these buildings, to understand actually how they would be managed, and so that we could look at what is the lowest carbon, but then also what is the lowest cost as well. And that was really useful to do at a really early stage. So we started that at stage 2 of the design. So that would actually make meaningful, it would inform the design as we went through, rather than just doing it, you know, as an exercise that we then couldn't use the results. So this is just a bit about kind of, you know, the strategies that we then started to employ from a design point of view. So especially around the well standard. So the well standard, for those who aren't as familiar, it looks about 50% of the points that you are available is around the design of the building. And 50% of the points are also around how that building is operated and who operates it from a management point of view. So we worked with CISL around things like their HR policies, as well as University of Cambridge, as I mentioned, around, you know, making sure as part of their annual maintenance strategies, will they be doing ongoing water testing, ongoing air quality testing? Was there scope to look at continuous monitoring of things like air quality in the building? And that would mean that not only did they get sight of it from an FM point of view, but also looking at integrating that back to the users so they could see, you know, the quality of their spaces. And go back to Wendy's point around, you know, the ventilation strategy. Is it about, well, then actually, if we have openable windows, that they should be opening those windows when the outdoor air quality is of a good quality, that's not detrimental to their health, as well as looking at the energy strategy. Another key part then of that design element for the well standard was looking at what space types. So well very much focuses on how do you support the occupants through things like, you know, making sure there are spaces where people can have breakout space and go and eat. So encouraging people to move away from their desks. We did look at things like restorative spaces, so spaces where they are dedicated to not doing work, and also spaces for kind of exercise. Not all of these spaces were incorporated into the final design, because there's obviously space constraints that had to be combined with, you know, meeting spaces that they required. But it was quite interesting to have those discussions at the start, and again through those collaborative workshops, getting feedback from the end users of what kind of spaces they would like. And then there was also part of that, so lactation room was included within the building that was combined with a first aid space. And that was something that I think, again, is something that a lot of users are wanting to see in buildings from a facility point of view. And then the other strategies were just around, you know, how do you create good acoustic environments? And again, that link to materials. So we looked at, are there any innovative materials out there that could provide acoustic properties, but also were bio-based to help with our bio-based targets. And there was, you know, we talk about all this, and this project wasn't without its challenges. I think it's worth saying that. And it was about how we take these challenges and learn from them. So one is, I suppose, how we overcame them, and two, then how we learn from those challenges for projects going forward. And there was things around, you know, yes, we can use innovative materials, but then there's questions around fire safety and how well those materials had been tested. So from an insurance point of view, could we get insurance if we're using materials that don't necessarily have a track record? So that was all sorts of things that were in the conversations through the design process. And then I won't go too much into detail of this. This was kind of picking up on Wendy's point. So materiality was a really big part of the design decisions that we were making. And that was because from an embodied carbon point of view, for the fit out element, because obviously the majority of the structure facade was getting retained, actually then the materials that were going in as part of the fit out were a massive contributor to the embodied carbon in terms of proportion and percentage wise. So it was really about how we can look at maximising the use of low embodied carbon materials, but also looking at, do we need these materials? Where can we actually emit materials? Because that is the best way of reducing your embodied carbon, by just not having any of those materials in there. And this is something that I think probably over the lifespan of the project, it's been really good to see just what different materials are out there. And this is one that we've used, especially at BDP, on future projects, of going, oh, actually, no, I think we looked at this on CISL. In 3 years, has it been tested on other projects? You know, cost was a big thing as well, because if you're using materials that aren't necessarily typical construction materials, they tend to have a higher cost. So it's just looking at where the industry is evolving, and there's lots of now, you know, databases coming online with low embodied or high bio-based material options that architects and interior designers can start to use. And then just touching a bit on the services as well, because I know Wendy was talking a lot about kind of the architecture. And so one of the things we did was look at the existing building in terms of what kind of kit was in there and what was the existing engineering strategy. So we did walkarounds of the building to have a look at that. And then we started to look at, okay, is there anything we can actually reuse? So just like the floor finishes, is there any bits of engineering kit in there that, because, as I mentioned before, because the structure and facade were getting retained, the fit out materials, but then also the MEP was quite a large embodied carbon factor, because a lot of the kit, because we were changing the heating and cooling strategy, that obviously required new kit going in. So we just started to look at, is there anything though that there's potential for retention and reuse, or looking around and going, actually, yes, we could definitely reuse that in the existing building so that we wouldn't have to go for a new high carbon option. And then one of the brief requirements was we were looking at decarbonising, so taking out requirement for gas within this building, so having an all electric building. And this was where the engineering and the architectural strategies really needed to be intertwined, because it was all about, okay, if we create a thermally efficient and airtight building, that means using an air source heat pump strategy would be a lot more effective, and that would allow us to have this all electric strategy and have no combustion on site. We also look quite detailed at the thermal comfort. So one of the aspects of driving down the energy demand was looking at, can we bring in natural ventilation and cooling where possible? So this was about what times of the year. We did lots of modelling and studies to look at what times of the year could the windows be open, knowing that probably in the peak summer months there would need to be some elements of cooling, but it was almost trying to just eke out and maximise the amount of time you could get some of that natural cooling into the building. And then supplementing their air source heat pumps, we wanted to look at, was there other technologies we could look at from a low and zero carbon perspective? So having available roof space was really important, and CISL wanted to have a usable roof terrace for entertaining and events. But what we were able to do was create a PV canopy structure, because we said, well, actually, you know, it seems a waste to have that roof that you can't then generate some electricity from it. So we did also look at putting PV, which was in the final building, and that just then helped to generate some additional renewable technologies on top of the fact it was already a low energy demand building from the EnerPHit certification. And then just going through one of the things, you know, we had that project charter at the start, but it was making sure that this thread of high sustainability aspirations continued all the way through, not just the design, but then didn't get lost in the tender process and through to the contractor as well. So we had a great contractor team with ISG, and we made sure that as part of the employer's requirements and tender documents, that all of these sustainability requirements were captured in that, so that ISG were given, you know, a footing of what was expected from the project, and making sure that things weren't necessarily changed from that design process or value engineered out, so that we could maintain that high aspiration. And then just finally, just on the outcomes, so we have achieved BREEAM outstanding, and we have it at design stage. We are just looking at completing the post-construction stage, but it's on track for BREEAM outstanding. And as part of that, we did get an innovation point for circular economy, which Peter Kelly will talk more about, which was really good, because the BRE don't tend to give out innovation points very lightly. We're also on track for WELL as well. So we are just finalising testing and getting the last bits of documentation together for that. And then these two images, the two right images, are the Entopia case study. So everyone within the team and within CISL have produced a summary document and a more detailed document that talks about, you know, the process we went through, some of the key achievements for the project, as well as some of the challenges. So if you can share the link, it's definitely worth a read if you haven't seen that case study. And then just finally, the highlight for me for the project. So the now King Charles, was Prince at the time, kindly came and looked around the building and officially opened the building. So this was me just talking him through what the aspirations were and what we did. He did have a couple of comments on the floor finish of where the carpets were going to go down, but I think we convinced him that the exposed floor finish was good, and he seemed really receptive and really pleased with what we were doing for this project, and hopeful that we could use this for future projects going forward. So that was really nice, and hopefully a picture I'll keep on my mantelpiece for years to come. And that was me. Thank you.
Brilliant. Thank you very much, Lucy. I believe we're going to go straight into Peter Kelly's presentation. Are you there, Peter?
I'm here, yes. Thank you. I
Can't
won't
see
share my screen just in case I crash again, which is probably lucky for most on the call anyway, but let's see if this works. Can you see that?
Yep, that looks good. Thanks.
Excellent, thank you. Okay, so before I go into a bit more detail on the circular economy aspects, I just wanted to touch a little bit on some of the challenges we faced when we started doing the construction piece. So one of the key outcomes from this is to strip back the building first, because you just never know on these types of buildings what you're going to find. And one of the things that we really didn't expect to find was a heating trench, particularly on the first, second and third floors perimeters. But obviously when you've got a trench like that with a lot of pipework in it, crisscrossing floors and going through walls, it's in the worst position in terms of trying to prevent thermal bridging and making sure your air tightness is correct. But also a lot of penetrations as a result of that heating trench through walls, etc. So a real conundrum. We had to try and find a low carbon solution as well that would work because of the embodied carbon element to it. And of course, we had to make sure VOCs and everything for BREEAM lead, BREEAM and well, etc. were meant. So all of these things have knock-on effects once you start taking into consideration all the other sustainability aspects of the project. Again, the columns weren't in great condition when we stripped them back. That meant that we had to improve for fire performance in particular, and obviously aesthetics, which meant introducing wet plaster, which wasn't planned for the project and had an impact, as you can see from the raised access floor, particularly on dust, which isn't a great thing we wanted to introduce because of the high quality air requirements for well certification. So we came across quite a few challenges. The ceiling on the picture with the columns, you can see some bituminous material that stuck the tiles to the ceiling. That started to leach through in places to the ceiling finish. So that had to have a treatment on it as well, which again meant we had to make sure it was compliant with all the sustainability aspirations. So some real challenges unearthed that we weren't expecting when we stripped the building back. I'm not going to read this all out, but I'm sure the slides will be distributed afterwards, so I left the detail there. But I think it's been mentioned a couple of times, some quite unique materials, certainly not used on this scale of project before, certainly definitely for diathanite anyway. So we had to do a lot of testing, a lot of mock-ups to make sure that everybody was confident that these solutions would work, and that the installation of these solutions was correct by the subcontractors, because these are quite specialist subcontractors, but they were excellent and worked really well with our existing fit-out contractor and taught some of their operatives how to apply these products to make sure that future they could be applied by more than just themselves in the future to broaden the use of these materials. So again, the bio-based very highly aspect of this. The sauna spray, I can't recommend it highly enough, particularly for raised access floors. We thought acoustics would be an issue, but the sauna spray does such a good job of dampening that sound. So some really good materials. Typically, if we hadn't hit COVID, they would have been easier to source. But once we hit COVID, that put us in delay. And then, of course, we hit wonderful Brexit, which meant that as largely these materials are European, we had trouble getting them to site on time. So a couple of issues that obviously, hopefully, in use of these materials in the future wouldn't occur, because hopefully there won't be another COVID, and hopefully there certainly won't be the implications of Brexit at that time as well. Obviously, construction was a challenge because of the amount of detailing in the different parts of the building, which Wendy touched on. I won't play these Vimeo links now, but we had to put together some really good visualizations of the different elements and the different wall build-ups to make sure that everybody understood the different installation techniques and the different materials and which order they were installed, etc. So it's very difficult, obviously, to pick that out on a 2D drawing, and much better if we could visualize that for everybody to agree, and then obviously with our supply chain to make sure when they're doing the mock-ups in particular, we got that right, and then they could carry on throughout the floors and make sure that all the different types of installation and materials, etc., were correct. So as you can imagine, lots of hold points, lots of quality control, etc., to make sure that everybody remember the correct detail and the right installation sequence. So moving on to the circular economy aspirations, we have our own circular economy policy, which aims to change the way we hopefully design, procure and install materials, etc., so that they can be reused, repurposed and remanufactured at their end of life or end of use, hopefully at their highest value without causing adverse environmental impact, at cost neutral or less. And this project was an exemplar for that. I'm going to start with some of the reuse of the materials that we managed to implement here. But what's really important is clarity around what you need when you're going to reuse materials on this scale. You need a donor site. You need the logistics on that donor site to be able to carefully take those materials down, palletize them, store them in an appropriate place, and then hopefully transport them. Then you need a storage facility, which particularly in and around London and the southeast Cambridge area is quite expensive. Then you need a platform that allows somebody to advertise that you've got those materials, so somebody may know that they're available for reuse. And then whoever's storing those materials needs the ability to redistribute them to wherever they're required for their onward reuse. So in this case, Lucy mentioned it, we got a 1% uplift in BREEAM for innovation points, where we removed circa 350 LED strip lighting from St. James's Place in London, which was a Cat A fit out we were fitting out for a client. They obviously wanted to change that Cat A space into something different, but thankfully for once made sure that they put a requirement on us to reuse as much of that Cat A as possible. So fortuitous timing, which is always the case when it comes to reuse, that we were able to carefully remove those lights. As you can see, they're meant to be installed in a ceiling. We sent them via Collect Eco, which is a company that specializes in this kind of reuse, back to their warehouse. We then managed to contact the original lighting manufacturer, Specials Lighting Design, who I asked if they would test and honor the warranty on these if we reinstalled them. They said they'd never done it before, but why not send them back to them? They knew exactly where they'd been installed and how long for. Cat A space, rarely used. And then we paid them to do some uplighting with some LED strip lighting and add some wires so we could hang them in the new CISL. So you can see here, even though they're not meant to be installed in the ceiling, they look really, really good. You would never know that they're secondhand in theory, although they were rarely used, as I said, in St. James's. For the whole look and feel of the CISL office, you can see how well they fit in. So absolutely delighted with that. And the BRE couldn't find a case where something like this had been done before, hence giving us that extra 1%. Moving on, we managed to source some specialist lighting from Signify, the former Philips lighting. Again, I won't spend too long here, but basically these pendants can be reground down and reformed back into pendants, again up to 5 or 6 times. They're very low in body carbon, etc. So really good product, really innovative, and as you can see, look excellent now that the project's finished, and not just here in the reception area but in the kitchen areas, etc. as well. So we're really delighted with the installation of those. I would note that there was a lighting design for CISL, but obviously when it came to stage 3, we pivoted away from the original lighting design and redesigned it to incorporate those lights from St James's and these lights from Signify. Eternals movie. So again, I managed to source some steel which came originally from this movie. It was used as the rails to run the cameras on. When they'd finished shooting, was about to go in a skip. Luckily, there was a gentleman called Charlie Law who was working there at the time, who I know well, who salvaged that steel and sent it for reuse to a company called Cleveland Steel. I know Roy well at Cleveland, so I rang him up and said, I don't suppose you've got any appropriate steel for our PV canopy? And he said, well, funnily enough, I just had a load promised to me. What do you need? So I managed to send him the steel sections we needed. He said he could make it work with a minor rejig of the design. That took about a couple of hours by our structural engineer. And you can see nice rusty steel here, reclaimed from the Marvel studio, that by the time was cut to size, galvanized, and brought to site at CISL and installed. So the great thing about this is we had the original paperwork from Charlie that came from the studios that allowed the reuse protocol for steel to be enacted, meaning that the fabricator, the installation contractor that worked directly for us, ISG, could easily treat it as if it was brand new steel, and they didn't really matter to them whether it was secondhand or not. We had the requisite paperwork to take any risk or warranty issues or whatever it was away from them. And then finally, we were doing the Netflix fit out in central London at the Copyright Building. Their security demands meant that they had to reconfigure the reception space. This beautiful piece of furniture had been only in for 6 or 7 years, designed by Piercy & Co. Absolutely top quality design in terms of its detailing. Also Bill Amberg leather that you can see on one of the pictures there. We managed to salvage that because it was going to go in the skip otherwise. Luckily, Benchmark Joinery, who made it, were on our supply chain. They came in. It did take them a lot longer than they anticipated to remove it, and they acknowledged that they need to start designing their furniture for circularity and not for long-term installation. Unfortunately, the Tavatine top was broken, but we managed to salvage some of it. They did need to modify it anyway for CISL's requirements for wheelchair access. So it all worked out pretty well in the end, and you can see it here beautifully installed in the reception area of CISL. So that was a real plus point and really sets off that reception area. I just want to give a brief shout out to the UK GBC System Enablers report, which was launched last week. I was part of that team that certainly reviewed it anyway and made sure that we think it's a really good piece of work. So in terms of some of those enablers that are very specific to construction, I think we've got a long way to go. Materials market doesn't really exist and is not mature enough. We're not doing enough circular economy audits to identify materials for reuse. We haven't got agreed metrics around what we should measure and monitor. And then we're still design for manufacturing and assembly, but not disassembly. And there's a lot of thinking around materials passporting, but again, it's not widely undertaken. So a lot of work to do in this space if we're really going to change how we work in terms of circular economy. So just a brief slide on post-occupancy, which is going to be a huge part of this project. we're contractually obliged to stay for a considerable amount of time and make sure that this building is working correctly and as designed. We've got some really good kit installed to almost bypass the BMS and go straight to some software that allowed us to monitor all the sub-metering. As you can imagine, in this building, it's sub-metered to death. So we're really able to pick up very closely the energy consumption and make sure we're on track. So we're really looking forward to getting that post-occupancy in, really in swing. And then I'm sure there'll be more publications in due course about how the building's performing. So just to wrap up, we really feel that these deep green retrofits can be done. There is a report on the CISL website that talks about the costings, so well worth a download and a read through. Once you take out issues that wouldn't ordinarily land again, like Brexit and like COVID, then we're very much within the range for a standard retrofit. The standard materials you buy off the shelf won't cut the mustard if you're looking at really sustainability aspirations that were on this project around bio-based, managing to be in line with Wi-Fi monitoring, modeling, etc. So, you know, it's a challenge, but we must use more of these types of materials and make sure that they become more frequently used. And then I mentioned it before, but we would have saved a lot of heartache if COVID hadn't prevented a lot of the strip out while the design progressed. But you know, we overcame those issues as contractors always do. But it would have been a bit easier if we didn't have to redesign some of the areas particularly for air tightness. So there's as was mentioned, there's been lots of publications. We'll distribute the slides, obviously, and there's plenty out there in a lot more detail than we've covered today. So please help yourself if you're interested, and there'll be much more to come as well as we learn more about the building operating going forward. So that's it. I'll stop sharing now and we'll welcome any questions.
Thank you very much, Peter. We've got quite a few questions popped up in the chat. So I don't know if everyone wants to share their cameras so we can see who's speaking. So yeah, guys, for the panel discussion, the whole team, so Wendy, Lucy, Peter, and we're also joined by Patrick, who's the project manager on the scheme. So yeah, just keep asking any more questions if you got. I guess one of the first ones, quite a nice one. What are the key lessons that you learned on this project that you're going to take forward in your work, from Susie?
I think Peter's already mentioned some of them there in his final slides, and I definitely echo the one about opening up as early as possible. It was something that it was quite tricky to do on this project because of concerns from the university, but it certainly would have helped us a lot to know as much as possible about the building. I think from a planning point of view, we had those early discussions with planners, and it really identified that the change to the windows was going to be of particular concern. So it meant we could really focus on that as an issue in the planning application and kind of prioritize that in terms of the time and effort we were putting into making the arguments about why we should do it. Whereas other changes, the addition of the PV canopy on the roof were much less contentious. So, you know, obviously we needed to explain what we wanted to do, but there was no need for any of that backup information. Don't know, Lucy, Patrick, anything for you?
I think that just from my point of view, the whole going back to the project charter we set in place and the way the team worked together, the thing that I've taken forward to most of my projects now is that the art of the possible, what a team who are working well together, designing out these principles can actually achieve. Some of the things we got to would not have been, we didn't even envisage it at the start of the project. It was the relationship between all of the team members that really drew that out. So my challenge is to make sure I create that culture on all of our projects going forward.
Yeah,
I think I'd echo that as well. I'm just saying, I think for me, one of the lessons learned is about actually, you know, starting from a point of why can't we do it, rather than, you know, suddenly going, oh, well, that's never been done before, or no, that'll be too difficult. You know, this project we always knew was going to be challenging from the start. So I think we approached everything with, you know, this is what we're trying to do. And as we said, some of those targets, you know, the embodied carbon target, the bio-based materials, yes, we didn't achieve what we'd originally set out, but it was more about, we tried and we looked at what, you know, why haven't we been able to do things, and then taking those lessons learned so that we can inform future projects, I think is really important.
Yeah, I obviously I can't turn on my video, it'll just crash, but from my perspective, again, I just echo that this was the first project where the client did not divert their sustainability aspirations one iota throughout the project, and that meant that from a contractor perspective, everybody bought into that ethos, and it's the first project I've ever been on where everybody was so scared to make a change without making sure it went through me first, and then Lucy, and then Wendy, to make sure that there was so many gateways that nobody introduced anything that would put any of the sustainability aspirations at risk. So it was great from that perspective, because everybody bought in, everybody wanted to achieve it. And what's great about it is everybody's really proud of what we have achieved, and really looking forward to the next one.
Sounds like it was a real pleasure to work with a kind of ambitious team and with an ambitious brief, and yeah, sounds great. We've got
also without its moments, I must admit.
yeah, I can imagine, like all projects. So another question is from Francisco. Were the carbon impacts from labour and machinery an important part of the life cycle carbon assessments for the retrofit and removal / updating of existing finishes?
So they were factored in using the RICS methodology. So as well as the site wastage proportion of materials, which goes into the kind of each individual materials assessment, we also had a kind of general factor, which was based on a 1,400 kilograms of CO2 per 100,000 value of construction contract, but adjusted to current values, to cover the kind of works on site. So the kind of site machinery, site cabins, generators, any of that kind of site stuff. It was a bit of a, or it is a bit of a grey area in the RICS guidance. So we kind of hopefully were quite conservative in that we chose to do the site wasted materials and that on top. So hopefully between the two, we've fully covered it.
Would anyone like to add anything else on to that before we move to the next question?
No, I think Wendy was the expert and did a fantastically detailed job, particularly when you're working with an academic institution. We had to make sure that every single data point or every single metric that we used was absolutely spot on, because as you can imagine, in an academic world, someone would soon tell us if we weren't doing it properly. So it was a lot of pressure on poor Wendy to make sure that everything was perfect, and she did a really good job and worked really hard on it.
I think I'd just kind of qualify that about being spot on, because I think with embodied carbon, it's very much emerging information, and we were only able to work with the information that's available at the moment in terms of embodied carbon data for materials. So as part of the reporting that we put together for a client, we wanted to be really transparent about what we've done, so that if in 5 years' time someone wants to come back and try and recalculate it based on better data, it could be done. So we were really clear about the quantities we're using, the materials that it was based on, and the embodied carbon data that we use for that materials, because although some materials do have their own bespoke EPDs, there's actually quite a lot of things where you're having to look at either a similar material or a more generic database of carbon data. So we had to do all that, and we tried to explain it as clearly as possible about how we'd come up with the figure.
Have you guys kind of set any responsibility moving forward within the next few years, that if in case they want to do a reassessment like that? Just out of curiosity.
I don't think so. There is a separate exercise going on. I'm working with the interior designer and the client to try and put a figure to the FF&E embodied carbon, which is in many ways more difficult than the building embodied carbon, because there's really much less information. So again, it's a bit of a trying to be as transparent as possible about how we're doing it and what assumptions we're having to make to do that. But at least trying to come up with a figure in some way.
Thank you. We've got a question from Caroline Slater, who asks, who says, it sounds like the client and brief were very important to the success. And she's asking, have you got any advice for helping clients work this out for themselves and to be good clients?
I mean, for me, I think one thing is using projects like this to inform your brief. So looking at other projects where it's worked well, and being able to take those lessons to kind of set out what you want to achieve. And I think just having a clear vision as well. So looking at, depending on what your organisation is, what is your overarching sustainability aims, how do you then start to translate that? If you've got a project, how do you then translate that into a brief? And there's lots of now guidance kind of coming out there as well, almost in the industry, of guiding you to how to write a sustainability brief. And probably when I started out about 10 years ago, there might have been one line in a project brief about sustainability, or even nothing, whereas now it's almost, there is a separate document that is the sustainability brief for a project. So I think, as more and more projects like this deliver, I think using those lessons learned and getting those to try and inform what you want to achieve from a brief and what's something that's achievable.
I think it was really important as well to have metrics. And for, in this project, obviously we had things like EnerPHit Classic and WELL and BREEAM, which have their own internal kind of QA systems. But for things where there isn't that, like the bio-based percentage and the embodied carbon, obviously there are metrics that we can measure ourselves. So there was a figure set, and even if we didn't necessarily meet it in the end, at least we could measure ourselves against it and see where we sat. It was actually something with the circular economy that I remember talking about in one of the collaborative workshops. Can we actually set a metric for this so we can kind of measure how well we're doing? And I don't think we actually cracked that one. Obviously, I think we've done incredibly well. There's so many different stories around the circular economy, but it'd be great to be able to kind of measure it somehow or kind of quantify it.
Sounds like a gap in the market to me. Shall we move to the next question? So from Abdullah Mahmood, we've got whole life carbon optioneering versus whole life cost optioneering. Were there any noticeable correlations or trends between the two outcomes? For example, was the lowest carbon always the highest cost? Or,
Probably best for me to try and answer. I'm not sure I can answer the specific point, but we did do a very detailed end of project cost review, looking at what was the extra over cost of EnerPHit and the sustainability uplifts. The costs are actually pretty comparable. I think we worked back, it was something like only a 5% uplift on original cost. So on that basis, does it cost more? No. I think you just got to work the design that much harder to achieve it, yes. But in terms of capital cost, it shouldn't cost more.
Brilliant. Does anyone would like to add anything before we move on to the next question? No. Okay. As a design team, how did you go about specifying elements which you wanted to source via salvage, and how early did you decide what to salvage?
I think that's a really interesting question, because we actually found it really difficult in the early stages. We did some kind of discussion with the university, because as they control a relatively large estate, we wondered if there were any sources of waste materials from within the estate that we could take and use. And it was very difficult to identify things. I think timing is really key. So we were talking to them 3 or 4 years before the project was actually completed, and so it would have been kind of 2 to 3 years before any materials would have been needed. So even if they did have some materials then, how would they store them? How would they kind of keep them for that period? So although we explored it a lot, and we knew that we wanted to do it, it was incredibly difficult as an early stage design team to actually specify that. So I think the only thing we could do was kind of be explicit about what we wanted to achieve. And I think it was really ISG and their design team coming on board and having these connections and networks and we were that little bit later in the program, so that we were closer to when the materials were actually wanted. I think that really unlocked it for us. So I think it's about, from my perspective, it's about being clear about what what you want to achieve through that, and being flexible enough in terms of the specification to be able to say, yes, we can kind of tweak that or change that, or for example, the lighting, we changed lighting design, and that was okay. You know, we didn't kind of say, oh no, hang on a minute, that doesn't meet the specification that we set out at stage 3. We knew that by changing it, we were achieving so much more in terms of the circular economy.
I'd agree, Wendy. Your flexibility point is key to getting the university facilities team to actually acknowledge that a second-hand light might be okay in one of their new buildings. Was quite a shift in approach that we had to take them on that journey.
That's great, thanks guys. You spoke about negotiation issues with planners about windows. Were there any other issues that arose in relation to planning?
That was really the key concern. Yeah,
I think there was a point with the planning process where the client, the wider university, would at one stage would have accepted the conservation officer's requirements and would have accepted a relaxation, if you like, in terms of the windows. We managed to keep them on message, and for them to then go back and back basically the project team's desire to get to this point. And I think without that, I managed to get the university to the point where they would have gone to appeal if the planners hadn't accepted this route. We obviously didn't need to, but to get them to just thinking that was the requirement, managed to help us all convince the planners to take a different view.
That's great, thanks. Were there any organisational challenges of working collaboratively, and how were they overcome?
Oh, one or two. I think so. Yes, all projects get fracture, shall we say, at different stages, particularly when you've got a tight commercial brief that we had. The charter which we put in place was put in place at a time on the project where everyone was working well together and all focused on a brief. It was when it got particularly heated at some tricky commercial discussions, more so within the client's organisation, to be perfectly honest, that I was able to use the charter to go, actually, just remember you did say we were going to work like this. So this is how we're going to play it going forward. Peter mentioned the challenges the contractor had with Brexit and COVID. Those are not easy things to deal with in a normal project, let alone when you've got this added layer of complexity. So it took a very open and collaborative approach really with ISG to understand where the true costs were and where their challenges were, and see where we could find the right answers together. Not sure if you'd add anything to that, Peter.
Yeah, I think, look, we would have loved to have just delivered the project, but of course we got hit with these two conundrums that obviously we weren't expecting either, because if we hadn't had COVID, we would have been able to deliver the project before Brexit kicked in. But that's what contractors do, don't they? They pivot and practically try and solve issues. So I just come back to the collaborative nature of the project. It was something that Patrick told any contractor that wanted to tender for this project, even at pre-qualification stage, that this is not a commercial decision 100%. It is who can we work with and partner with that can deliver the aspirations of this project, because it is different and it's going to need that collaborative process, that leap in faith, that whatever you might term it, to take on some risk that maybe we wouldn't ordinarily, and to try and mitigate that risk as quickly and as efficiently as we can, so we didn't blow the budget for ourselves and for the client. And I think there's always some fraught conversations, but I always said if we were all sipping champagne up on the roof terrace at the end of the project, then we did a good job, and we have done in the past. So I think we can all say that despite the challenges, we're all proud of what we achieved, and we're still talking. So that's the main thing.
On that note, did any contractors kind of hold their hands up and just say, we're not prepared to be involved in something like this, or were people quite ready to adapt?
Well, we kept the supply chain really simple because the building is really simple. The difficulty is the wall build-up, but once the wall build-up's complete, the rest of the project was very, very straightforward. It's a small amount of steel underneath to support the roof, the PV canopy, but the installation of that is relatively straightforward. Very little partitioning. So the actual fit out was relatively straightforward. So what we made sure we did is pick a really, really good fit out contractor that was willing to work with these unusual materials and learn themselves to deliver that wall build up. So that was the key, really. We used Stortford Interiors, who have been around for a very long time and work for a lot of major contractors outside the London. They did an excellent job. They were willing to embrace the ethos of the project, that collaborative nature. And I couldn't give them more praise, really. I can't think of any time that we came to blows, or they said we're losing time, or we can't get enough people to do this, or the subcontractor's not working for us. Everybody pulled together, because at the end of the day, we knew we had to hit that airtightness requirements for EnerPHit, and everybody was so laser focused on making sure that the quality control was so high, because obviously if you've installed that building and you saw some of the pictures of it finished, if it doesn't meet the air tightness levels, what do we do? You're absolutely stuffed. There's no way you can go around and just cover the whole thing in sellotape. So we knew we had to make sure that it worked first time, and that meant that we had a supply chain that were bought into that ethos. We had Kershaw's, who unfortunately have gone bust on M&E. They joined us literally from day one. From the pre-qualification stage, we used them, and then from the tender stage, they were right by our side throughout. So we had an M&E contractor. We brought Stortfords in. We did the visualization. We did a lot of the detailing with Wendy and Fielden Mawson, and thankfully, it worked out and we passed. And as I said, everyone's happy.
Great, thank you very much. We've got another question from Mark Power, who asks, how have the new hybrid working patterns modified in-use calculations you were originally working to? Probable lower occupancy levels impact on thermal performance of the building? Would you make different fabric decisions now in light of these?
We don't have a kind of full set of, or a kind of annual set of data yet. So we're kind of still waiting to get the feedback from CSL. But our experience with working with Passivhaus design is that it's usually fairly flexible. And we completed a new build secondary school, Harris Academy Sutton, which was being occupied kind of year by year, adding an extra year group in. So in the early years, you had this massive building with just 1 or 2 year groups rattling around. And so initially what we found was that the heating energy was higher than anticipated, because there was less body heat generating heat and they had to put extra heating energy in. But that was actually offset by lower electricity. So there were more classrooms where the lights were off all day. There were fewer devices plugged in. And then year on year, it's been building up, and they're not quite full yet, but I think they're a year or two off. What we've seen is that trend kind of gradually starting to reverse and getting back to the kind of anticipated design position. So the heating energy is coming down, but the kind of plug-in loads are edging upwards. So I anticipate it's probably similar. I think we're going to probably find similar results here, and obviously we wait to see them. But it is true, there's probably going to be fewer people in the building than we initially anticipated. But I guess if anything, it will just mean that there will be slightly higher heating inputs and slightly lower electricity plug-in load usage.
I would just comment that we probably acknowledged, particularly Patrick and I, when we've discussed this, is that the building performs so well with airtightness that it may be slightly over-designed because we weren't sure it would work. So there's layers of blower proof in there, sealant, etc., that perhaps in hindsight we may not need in the future. So that's a good lesson. We did a test with a couple of the floors weren't even complete, and we nearly passed. So we were pretty confident that the airtightness would work, but perhaps slightly over-designed, and we could row some of that back a little bit in future projects.
It's true, the airtightness is amazing, isn't it, on the building? I think it would be good enough to pass a new build Passivhaus project. I mean, there are obviously other elements to being certified as Passivhaus, but it is that good.
Great, thank you. How successful were you guys in recycling materials that were stripped out of the building originally?
Well, thankfully, there wasn't a massive amount of materials. It was largely furniture, which we sent either to Collect Eco or CISL or the Cambridge University took for reuse either in this project or elsewhere on their estate. So we partnered with a company called Collect Eco that carefully removed anything that was able to be reused. Obviously, it wasn't in great condition. It hadn't been touched since the 1990s. So you have to be careful with how reusable materials that are 20 years old, etc., are. But where possible, we reused what we could. But as I say, the carpet tiles were taken out, cleaned, and re-put in where they could, or Collect Eco took them and cleaned them and reused them. I don't think a lot of the ceiling tiles were available for reuse because of their age. Furniture was largely donated, recycled, or reused elsewhere. And I can't think of much else. A lot of the electrical kit was in good condition, had been really well maintained by the university and was retained. Some of it was a bit too old to be reused. But there wasn't a massive amount in there that you traditionally expect to be reused, other than the majority was furniture.
That's great, thanks. What were the big ticket items in terms of embodied carbon other than the floor finishes? Where did you manage to save the most carbon relative to using standard materials?
The big ticket items from the assessment that we did were, I think, the MEP carbon, but we didn't do a full breakdown of that using TM65, or there's an absence of EPDs for MEP carbon, so we used a percentage. So we kind of assumed if the entire building had been built new from scratch, what the embodied carbon of that might have been, and then used a percentage, I think, coming from the LETI guidance of what that might typically be for an office. So that's actually a very big number in relation to all the other embodied carbon, and it's an unknown, but it's kind of as good as we were able to do it at this point in time. I think this is one of these areas where it would be great if someone at a later date, when everyone has published all the EPD information, could kind of revisit that. And the other elements, yeah, the floor finishes were another big one. And actually the other big number in there was interestingly coming from the in-use embodied carbon. So the maintenance of floor finishes. So it might seem quite minor, but someone kind of on a daily basis, vacuuming or mopping the floors, whatever the floor finish, adds up over 100 years, and so that ends up being quite a big number, and quite difficult to design out because it's going to happen whatever the floor finish. Yeah.
How do you kind of quantify that maintenance, the carbon cost of the maintenance? It's
quantified in quite a few floor finish EPDs. And the ones that didn't quantify it, we just kind of reused the number from one or the other because they were all actually very similar. Obviously, they kind of slightly vary the process by floor finish, but it actually ended up with being a very similar number.
Thank you. Coming to the end, some of the end of the questions now. One of the final ones was there any strategy used to deal with moisture in the retrofit? And was there any difficulties encountered in the process of design?
So I think the internal wall insulation build-up was absolutely key to doing this. And Max Fordham, who were the Passivhaus designer in the later stages, did a lot of modelling of moisture movement through the proposed build-ups to work out what would be the kind of most robust strategy. So what we ended up with was, I think as Peter's mentioned, with kind of diathanite, so 2 layers of that totaling about 40 mil, and that's a kind of wet applied plaster with the cork granules in it. It also acts as our air tightness layer, but it also is hygroscopic, so it's helping with any moisture working its way through the solid brick walls. It means we don't end up with any kind of nasty mold situations kind of at that junction. And then we've got the wood fibre insulation, which is also vapor open, so that will all work in tandem with the wall. I mean, obviously, if there's any major leaks coming from the rainwater gutters, then that needs to be dealt with so that the walls aren't absolutely sopping wet, but normal rain can be dealt with adequately. And just to add to that, kind of from the survey point of view, it was kind of, we had talked at the early stage about should that be surveyed so that we can understand what's happening with that wall, and maybe we need to put in an external coating on the wall to try and reduce any moisture content of the brickwork. We ended up not doing that. Kind of interesting conversations about how do we know, because inevitably you have to survey it at individual points. How do we know that kind of applies across the entire building? And if we were to end up putting an external coating on, how do we know that that's going to be maintained 10 years, 20 years down the line? It all felt a bit risky. So it felt much more robust to do it as part of the kind of internal wall insulation, making sure that could accommodate the normal kind of ebb and flow of moisture through the wall.
That's great, thank you. And I think that's it. We're at 8 o'clock now. So thank you guys. Someone has actually asked if the slides can be shared after the presentation. I don't know if that's something you guys would be interested in.
I'm sure we could collate them.
We could coordinate something and maybe send it out via our socials to those interested. But yeah, thank you very much, everybody. Really appreciate your time given the presentations and for the panel discussion. Thank you everyone for joining. And also thanks to the tech team back of house. Have a great rest of your evening, everybody.